Hello everyone, in this video I will tell to you about BCD and Sevent segment and truth table of the BCD to Sevent segment, the Karnaugh map, and then the final result is the circuit of the BCD to Sevent segment. So before we start, let me introduce myself. My name is Madinda Dwi Marta with student ID 2415101054. So, what is BCD or binary code decimal? Binary code decimal is a form of number representation where each digit of a decimal number is represented by its own binary sequence. This means each decimal digit 0 until 9 is encoded as a separate 4-bit binary number. Here's how decimal digits are represented in BCD. So you can see in here. So another is, what is a 7-segment display? A 7-segment display is an electronic display device that can display decimal, numerals, and some alphabetic characters. It consists of 7 individual segments of LEDs arranged in a rectangle similar to the shape of the digit H. Each segment can be lit up individually to form numerals. The seven segments are labeled as follows. By lighting up specific segments, you can form the number 0 through 9. To display 0, light up segments A, B, C, D, E, and F. To display 1, light up segments B and C. And to display 2, light up segments A, B, D, E, and G, and so on until 9. Mapping BCD to 7-segment display. To control a 7-segment display using BCD, you need to map each BCD digit to the corresponding segment that need to be lit. So, the next video I will tell to you about the truth table of BCD to 7-segment. With me, Dinda, and now I will tell to you about the truth table with the material of binary code decimal to 7-segment. So in here, in the truth table, we have 4 inputs. It's A, B, C, D, and E. And this is the input, and so now I would write the output is A, B, C, D, E, F, G. 7 output. The last one is G. So now I will write 0 until 9 rows. And the last one is 9. So in here, the input, the binary code of 0 is 0, 0, 0, 0. Binary code of 1 is 0, 0, 0, 1. Binary code of 2 is 0, 0, 1, 0. Binary code of 3 is 0, 0, 1. Binary code of 4 is 0, 1, 0, 0. The code of 5 is 0, 1, 0, 0, 1, 0, 1. The code of 7 is 0, 1, 1, 1. The code of 8 is 1, 0, 0, 0. And the last one is 1, 0, 0, 1. So, how we make the output? How we know the value of this output? We can make the output with the illustration of the BCD to 7 signal like this. So in here, this is the illustration of the BCD to 7 signal like that. And this is the A, this is the B, C, D, E, F, and the last one in here is a G. So now we make the zero variable, the zero value. In here, we know like that. We know the sign of zero like this. So this one is 1 like A, B, C, D. The F has value 1 and the G is 0. And we make 1. If we make 1 like this, so this is A and B is 1 and the other is 0. How about 2? Same like before, we make 2 like this. So A, F, A, G, B, and C has value 1 and E and B has 0 value. E and B 0 value. E and B 0 and 1. So we make 3. The 3 like this. So F, A, G, B, and C is 1 and E and B is 0. E and B is 0 and the other is 1. How about 4? We make 4 like this. So F, B, and C is 0. C, B, and F is 0. And this is 1, 1, 1. We make 5 like this. So A and D is 0. A is 0 and the other is 1. How about 6? We make 6 like this. 6 like this. Right. So F, A, and Here, this is the A, this is B, this is C, this is D, this is E, this is F, and the last one is C. So, how to make the zero in the seventh segment like this? So, we make zero like this, right? So, A, B, C, D, E, and F has one value, and G is zero. In digital system, we know that one is it means to live and zero is die. So in here we need G to zero, and the other is one. How about make one in the seventh segment? So we just need we make one like this. So we just need B and C is to still alive, and the other is die. So B and C has one value, and the other is zero. How about two? We make two like this one. So A, B, G, E, and E is still alive, and F and C is zero. C and F is zero, and the other is one. It seems to 9, so I would make it 3 like this, 3. So A, B, G, C, and D is 1. F and E is 0. We need 4. 4 like this one. So A, E, and D is 0. A, D, and E is 0, and the other is 1. So the 5, we need 5 like this. So B, E is 0. And the other is 1. How about 6? We make 6 like this one. So the B is 0. And the other is 1. How about 7? We make 7 like this. So F, G, E, and D is 0. F, G, E, and D. D, E, F, G. And there is 1. How about to make 8, all of this is 1. And I will make 9. The last one is 9. So the E is 0. And the other is 1. So this is the truth table of the BCD to 7 segment. So that's the explanation about the truth table of BCD to 7 segment display. 1 means the segment is on, and 0 means the segment is off. Using the Karnaugh map, we can simplify the Boolean expression for each segment in a double segment display. from BCD code or binary code decimal. By simplifying this expression, we can design more efficient logic circuit for converting binary code decimal to 7-segment display. Now we can move to make a kernel map and simplify with Boolean algebra, and the last one is I will make the circuit from the simplified. So, so now I will tell to you about the A kernel map. Because in here we have 4 variables input, so we need 4 rows and 4 columns. In here, A and B has value is 0, 0, 0, 1, 1, 1, and 0. C and D to C and D has same like 0, 0, 0, 1, 1, 1, and 0. So in here we can see that if A, B, C, D has value 0, 0, and 0, 0, so the A has value 1. We can write 1 in here. So if the value of A and B is 0, 0, C and D is 0, 1, we can see in here the value of A is 0. So 0, 0, 1, 1. Value of A is 1. 0, 0, 1, 0. The value of A is 1. Next to another rows, 0, 1, 0, 0, 0, 1, 0, 0 has value of A is 0. 0, 1, 0, 1 has value 1. 0, 1, 1, 1, 0, 1, 1, 1 has value 1. 0, 1, 1, 0. 0, 1, 1, 0 has value 1. So because I just make till 9 BCD, so in here we just need write 1, 1, because we don't need the 10 till 15. So this is the kernel map of the A output. So I will make the according from the logism. The in here we have 4 things, and this is the simplify of this kernel map. So I will make the so this is we have 4 variables. This is A, this is B, this is C, and this is D. And we need 2 OR in here and 1 more, 1 N. And this is so we can see this is BXN and BXN. BXN and BXN. C is 8. So, this is the final result. The final result of a circuit and the Carnot map on A. So we can move to B Carnot map. So in B, we same like A, we make 4 rows and 4 columns. This is 0, 0, 0, 1, 1, 1, and this is 0, 0. So you can see in here 0, 0, 0, 0 have one value, 0, 0, 0, 1 have one value too, 0, 0, 1, 1 has one value, 0, 0, 1, 0. 0, 0, 1, 0 has one value. So next the other rows, 0. So this is the result of the Carnot map on B, so I will listen here. According to revision, in here we have 3 things. So I will make the circuit. This is we have 3 variables, B, C, and we made 2 OR and 1 and this is the. So this is B, this is C, and this is D. We know that B is accent, so we write like this. C accent, and C, and we will connect it to on gate and gate. So this is the result of B, of the circuit of B. So I will next do the C circuit from the Carnot map. So in C, same like before, we can see 0, 0, 0, 0. This has 1. So this is 1, 0, 0, 0, 1. This 1, 0, 0, 1, 1. This 1, 2, 0, 0, 1, 0. 0, 0, 1, 0, 0. This 1, 0, 1, 0, 1. 1, 0, 1, 1, 1. 2, 0, 1, 1, 0. 0, 1, 1, 0 has 1, 2. So like before, we can write this. According to logism, in here we have three things, and this is the simplified. In here we need three variables and one one or bit. So here this is B, this is C, and this is D. Because the C has accent, we write like this. So this is the I think this is the final result of the C circuit. I will next to the D. So like before, if we make this 0, 0, 0, this one, 0, 0, 0, 0 has one element. Zero, 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 zero has some value. 0, 0, 0, 1 has 0 value. 0, 0, 1, 1 has 1 value too. 0, 0, 1, 0 has 1 value. 0, 1, 0, 0 has 0 value. 0, 1, 0, 1 has 1 value. 0, 1, 1, 1 has 0 value. 0, 1, 1, 0 has 1 value. 1. So, because I just need 9 to 9, so the last I will see in reason. So this is the final result of the D Carnot map. So according to logism 2, in here we have 4 things. Accent, accent. So this is the simplified of the Carnot map. I will build the circuit. This is we have 3 1 or so this is B, this is C, and this is D. The accent and the accent here. The accent and C, the accent. So sorry. The first one is the accent and the accent. The accent and C, with the accent, and the last one is D, C accent, and D. So we connected to organ and output here. So I think this is the final result of the D circuit. So I will next to the E circuit. Same like before, if we make the map in furrows and columns. You can see a suitable of 0, 0 and 0, 0 is 1. 0, 0, 0, 1 is 0. 0, 0, 1, 1 is 0. 0, 0, 1, 0. 0, 1, 0, 0 is 0. 0, 1, 0, 1 2 takes. So we need 3 variables. And 2 and gate, 1 or gate, and the output here. So the accent and the accent. This is B, this is C, and this is D. The accent, the accent, C, and the accent. And we connect it to the OR gate and so this is the final result of the E circuit. So I will next to the F circuit. So same like before, 0, 0, 0, 0 is 1, 0, 0, 0, 1 is 0, 0, 0, 1, 1 is 0, 0, 0, 1, 0 is 0, 0, 1, 0, 0 is 1, 0, 1, 0, 1 is 1, 0, 1, 1, 1 is 0, 0, 1, 1, 0 is 1. So guys, same, I will say in example. So according to logism, in here we have 4 things or 4 groups. So I will make the circuit. In here we have 4 variables. And 3 and gate, and 1 for gate, and 1 on. So in here A, B, C, and D. C accent, B accent, B, and C accent, B, and D accent, and the last one is A. So we connect it all to the AND gate, to OR gate, and connect it to the OR. So I think this is the final result of the F circuit. 0, 0, 0, 1, 1 is 1, in here 1, 0, 1, 0, 0 is 1, 0, 1, 0, 1 is 1, 0, 1, 1, 1 is 0, 0, 1, 1, 0 is 1, 1, 1, 0, 0. So because I just made 12 lines, I will see in the window. So in here, 1, 1, 1, 1. According to the logarithm, so the circuit is like this. In here we have unit for parallel and 3 and 1 and 1 So the accent will be here and stay here. C and B and C accent. In here, B and E accent. The last one is A. So we connect it all to the whole gate, and I think this is the final result of the G circuit. I think that's all for me. I think that's all about truth table, coordinate map, and the simplify of the circuit. I will next to the simulation. How to make binary code decimal to 7-segment display in the logarithm. So, if you want to build a circuit A, B, C, D, E, F, and G, and you can make the mix of the circuit A until G in the logarithm. So, how to make circuit A, B, C, D, E, F, G before we start how to make the mix circuit. So the first thing that you need to make the circuit is you need to know about the truth table of the binary code decimal. In the previous video, I already tell to you about the truth table of the circuit A, B, C, D, E, F, and G, and you can click project in here and you can make analyze circuit and you can make the inputs here. So this is the inputs because the binary code decimal has four inputs, so we just need A, B, C, and D, and we need one output, and I make I use X in here to outputs, and in here we have tables. So if we want to make a circuit, you just need uh, take the value of A in here, and then you can this one. You can make the build of circuit. So this is, I will make the new one for the example. So in here, the first one is project. In here, project, and we need write the input and output. The output is A and the table. Now the table will be like this, and we need make the table of A. So in here, we repeat again. And output A. The output is A. And the table is 1 0 1 1 0 is 1 until 10 is 1 2 3 4 5 6 7 8 9 10, and we can build the circuit. So the circuit will be same like this, right? Because the truth table is same. Because yeah, if you want make the A circuit, you just need input the table of the A, and if you want to make the B circuit, if you want to make A circuit, you just need to take the value of A in the table of this project, and if you want to make the B, yeah, you just need to input the value of the B, and same like C, D, E, F, and G. So how about the mix circuit? The mix circuit will be like this. I already make the mix circuit, but I will explain to you how to make this mix circuit. So the first thing you need to make the mix circuit is you need to make this A, B, C, D, E, F, and G, because if you want to make the circuit mix circuit, this more efficient if you already make A, B, C, D, E, F, and G. So I will tell to you how to make it. So we need to make the new file, and so before we start, we need to name the input. We need to make the input first and the output. We don't need to make the output, we just need to take the input. So after this, we need to give this one. And because we already made A until G, we just need to drag this to here. Drag here and drag the B here. You must make it A, B, C, D, not A, D, E, or G, F, E, A. The A is in under and the G is up is not good because it's not efficient to our work. A, B, C, D, E, F, and the last one is C. So we need to connect all of this to the input. This is how I connect this one. So in this line we need to connect it in A and the other same. We need to connect it all of this to this line. And B, need to connect it in second line. So this is for B, and the third is C, and the last one is D. So we need to connect this for the C input. So we need connect it in here. So we need to connect it in the third line, and we must connect it all of this to the third line. the last one is for D input. So this is the we already make I already done make I already done to connect it to the input. And if I already done to make the mix circuit, no, because we need sorry, in here. Oh yeah, I forgot to connect it the other to the D line. So if we already done to make the mix circuit, the answer is no, because we need to connect it all of this to why it's like this. So we need to input the 7 segment display in here. So in this segment display in here, we need to connect it. This is for A, this is for A, this is for B, this is for C, D, E, F, and G, and this is for the dot. So we need to connect it in here for A, and this is for B, this is for C, this is for D. I'm sorry. This is for E. Sorry. This is for F, and the last one for G. So now I will try my binary code decimal to 7 segment display, and I want to prove it this is works or not, and I will try it now. So if we want to make 0, we need the first one is we need to know what is the binary code of 0, 1, 2, 3, 4, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if you want to make binary code of 0, this A, B, C, D must be 0. And if you want to make this the 7 segment display is 1, we need to make the value of D is 1. We need to light up of D, and if we want to make 2, we need to light up the C, and if we want to make 3, we need to light up C and D, and if we want to make 4, we need to light up of B, and if we want to make 5, we need to light up B and D, and if we want to make 6, we need to light up B and C, and if we want to make of 7, we need to light up B and C, B and C and D, and If you want to make 8, we need to light up 8 because the binary code of 8 is 1000. And the last one, if we want to make 9, we need want to light up the C, we need to light up B. If you want to make 9, the binary code of 9 is 1011. So my binary code decimal is proof, proof. Okay, I think that's all. I think that's all from me. Thank you for your attention and see you goodbye.